these circuits have a collection of different components in them. There's resistors, 2 kilo ohms and 4 kilo ohms for the question on the left, question 11 from the workbook. There's also an inductor, 3 millihenries, and a 5 microfarad capacitor. Now the thing about inductors and capacitors is that their response is not linear or constant with the energy that is applied to them. They change over time. So we're going to take a couple of different scenarios. And the scenario with question 11 on the left is an initial voltage. So what does that mean? That means that, it's not really clear here, but what it means is that this is at time equals 0, or when this 10 volts has been just at the point it has been applied to this circuit. So you could look at this as a switch, for example. So just draw in the switch, and at t equals 0, the switch is closed. And it makes a connection here. So how is that voltage going to be seen by all of these components? Okay. Now, if you've read through the workbook, you'll know that at t equals 0, capacitors act like short circuits. So when capacitors just see a voltage source, they act like short circuits. And that's because the energy supplied and current flows through them to charge them up. And because that current flows through it like that, it is essentially a short. So I'm just going to draw a line here to do the short. Inductors are different. When they first see the voltage, this big winding of coil winding resists that current. It's an electromagnetic force within the coil that slows down the current going into it. So it essentially acts at t equals 0 as an open. I'm just going to break the connection here. So you could view it as these nodes as terminals at t equals 0. So what then happens to the voltage if the capacitors are short and the inductors are open? The switch is closed. Then you have a voltage drop across the 2 kilo ohm, and you have a voltage drop across the 4 kilo ohm. And we figure out how much voltage drop by using the voltage divider. The total resistance, it's like a series circuit basically, is 6 kilo ohms. So the 2 kilo ohm is going to see 2 over 6, which is a third of the 10 volts. So 2 kilo ohm sees 3.33333 volts. The capacitors are short, so it sees 0 volts. The 4 kilo ohm sees 4 over 6 of the energy, or 2/3, so it's 6.67 volts. And that is also seen across the inductor. The inductor is in parallel with the resistor. Now it sees the voltage, it doesn't let any current flow in it, but it sees that at t equals 0. So the answer is down here for this circuit. Okay, taking a different scenario, question 13 from the workbook. Now looking at steady state voltage. So the battery, the 10 volt battery, has been in the circuit for a while and everything is settled down. The capacitor is fully charged. There's now no current flowing in it. And because there's no current flowing through it, it's fully charged, it acts like an open. The inductor has had current flowing through these windings for a while. And because the current's now fully flowing through the windings, it acts like a short circuit. So this is a steady state setup. So the inductor is a short circuit and the capacitor is an open. So now the 10 volts gets shared between a 2 kilo ohm resistor and a 4 kilo ohm resistor. Very similar in answer to the previous question. So now again the 2 kilo ohms gets a third of the voltage. The inductor now doesn't see any voltage drop because it's acting like a short circuit. The 4 kilo ohms gets 2/3 of the voltage, and because it sees 2/3, then the capacitor also sees 2/3, 6.67 volts. Okay. So the third question, it's again an initial voltage question. So let's quickly remind ourselves about initial. Maybe even bring this over. Oops. Okay. Okay. So initially, the capacitor acts like a short circuit, the current going through it, charging it up, and the inductor acts like an open. Okay. So now we've set that up, what's happening with this 20 volts? Well, because the capacitor is essentially a short initially, t equals 0, the 2 kilo ohms sees none of the voltage. All of the energy gets dumped down the capacitor. The inductor is an open. It sees the 20 volts, but it doesn't let any energy through it. So the 10 kilo ohm sees no voltage, but the 8 kilo ohm sees the 20 volts. Okay, so going to put the answer from the workbook here. So the 2 kilo ohm, the 10 kilo ohm, and also the capacitor have 0 volts. The 8 kilo ohm and the inductor, the 20 millihenry, see all 20 volts. Okay.